Hi, welcome back to Math 6, Module 1. Lesson 3 this time is about equivalent ratios. Our outcomes for this lesson are that students develop an intuitive understanding of equivalent ratios by using tape diagrams to explore possible quantities of each part when given the part-to-part ratio. And students will use tape diagrams to solve problems when the part-to-part ratio is given and the value of one of the quantities is given. Phew, that's a lot of math language. Hopefully it'll make more sense in a few minutes. We also have some math language in our second outcome that students will formalize a definition of equivalent ratios. It will look like this. Two ratios, A to B and C to D, are equivalent ratios if there is a non-zero number C such that big C equals C times A and big D equals C times B. I'd also like to remind you about the standards we're covering for this whole topic, that we will understand the concept of a ratio and use ratio language to describe a ratio relationship between two quantities. Also, we will use ratio and rate reasoning to solve real-world and mathematical problems. Excellent. So let's get started. This is in your module. Please take a second to write a one-sentence story problem about a ratio. That might seem like a little bit of math speak to you, so let me give you an example. I'm thinking about school and the number of days of school we have in a normal week. So the ratio of school days in a week to the total number of days in a week is 5 to 7. Then it asks us to write that in two different forms. Well, we can write it with a colon, 5 to 7, or we can write it with the letters in the word 2, 5 to 7. So now hit pause if you need some time to think of one of your own, because I am moving on. Shani and Mel are using ribbon to decorate a project in their art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7 to 3. So we're going to put that in a table. We'll start with the first piece of ribbon. Shani gets 7 inches, Mel gets 3 inches. But they might want more ribbon than that. They probably do. So we'll cut another piece. So now Shani has 14 inches and Mel has 6 inches. And if we give them another piece, now Shani has 21 inches and Mel has 9 inches. Hopefully that makes sense so far. So we keep going and it says draw a tape diagram to represent this ratio. So we have 7 units, pieces of tape, boxes if you will, for Shani's portion, and 3 units for Mel's portion. So it should look like this when you draw it. Take a second, draw yours right now in your module. If you need more time, then you need to hit pause because I'm moving on. So while you are drawing it, I hope you thought about what does each unit on the tape diagram represent. So let's say we made each of the boxes or each unit here count for 1 inch. How long is Shani's ribbon? You don't have to say it out loud, but you should at least have thought it. It's 7 inches and Mel's ribbon is 3 inches because that's how many boxes we have or pieces of tape. So what's the ratio? Well, it's 7 to 3. Remember, order matters. So when we got our original question, it says the ratio of Shani's ribbon to Mel's ribbon. So Shani has to go first. So when we look at these, Shani has to go first. Okay, so what if each unit represents 2 meters? So now it won't be 7 to 3. each one of these is 2. So I'm going to help myself visualize this by drawing a 2 in each box. So how many meters does Shani have now? We can count by 2s, we can multiply, whatever we need to do. So Shani now has 14 meters, and Mel has, will it help you see it if I draw in the 2s? Now Mel has 6 meters. So what is the ratio of the length of Shani's ribbon to the length of Mel's ribbon now? Well, Shani has 14 and Mel has 6. I skipped a question. How did you find that? Well, we multiplied or added them up. That's how to find it. Okay, next step. What if each unit represents 3 inches? I can draw in a 3. What are the lengths now? Okay, so add them up. 3, 6, 9, 12, 15, 18, 21, and 3, 6, 9. So our ratio, the lengths are 21 inches and 9 inches. Our ratio is 21 to 9. So we've just explored 3 different possibilities for the length of the ribbon. Did the number of units in our tape diagram ever change? Let's look at our tape diagram. We kept the same number of boxes every time. The boxes, the tapes, whatever you want to call them, did not change. So if you look at these 3 ratios, all of them have the same tape diagram. Yes? Hopefully that makes sense to you now. If not, put a star by this so we can go over it extra in class. Make sure you ask. But if it does, then let's move on. So if we look at the 3 different tape diagrams we had, all of the ratios are equivalent to 7 to 3. You remember when we looked at our student outcomes for this lesson, we said, okay, we want to have 2 ratios, A to B and C to D, that are equivalent if there is a non-zero number, C, such that, okay, so here we go. This is where it got crazy. If you think about the numbers that we put in the box, so this was our 7 to 2, and we'll say this was our, oops, it was 7 to 3, wasn't it? 7 to 3, and this was 14 to 6. So this number, 2, that was the number that we put in each of the boxes. So we took this A times 2 to get the second number, and this B times 2 to get the second number. So 7 times 2 is 14, and 3 times 2 is 6. It also worked when we did that. We had 7 to 3 and 21 to 9. We put 3 in each of the boxes. So 7 times 3 gave us 21, and 3 times 3 gave us 9. So this constant that we multiply by both of those numbers in the first ratio gave us the equivalent ratio. Okay, let me move down to where we were. There it was. So you remember that all of our boxes counted as 1 inch here. On this one, each box counted as 2 meters. And on this one, each box counted as 3 inches. So those numbers that are in the boxes are our constant that we multiplied by our original ratio to give us equivalent ratios. Okay, moving on with maybe a new problem. Mason and Laney ran laps to train for the long distance running team. The ratio of the number of laps Mason ran to the number of laps Laney ran was 2 to 3. So if we draw a tape diagram, it should have Mason with 2 boxes and Laney with 3 boxes. It should look like that. Remember, you should be writing this in your module as well. If you need some time, hit pause because I'm going to keep moving. So then it asks, if Mason ran 4 miles, how far did Laney run? So we know right now that these 2 boxes from our original ratio represent 4 miles. So if we're going to split 4 miles up into 2 parts, how much is each part worth? We're going to do some division. Hopefully that is easy in your head mental math. 4 miles divided into 2 boxes gives us 2 miles for each box. So since each box is worth 2 miles, if we fill that into Laney's box, we can use that ratio to find she ran 6 miles. Hit pause if you need a minute. Otherwise, we're moving on. So we have the same ratio, 2 to 3, Mason and Laney. But now we found that Laney ran 930 meters. So we need to figure out how many meters were in each box. So we're doing division again. 930 divided by 3. If you can do that in your head, that's awesome. If not, you do it out long division and you find that each box would be worth 310 meters. Since Laney's boxes are worth 310 in this part of the problem, that means Mason's boxes are also worth 310 in this part of the problem. So that means Mason ran 620 meters. So now we did 2 extra parts of the problem with equivalent ratios. The first one we did miles, and we learned Mason ran 4 miles to Laney's 6 miles. And the second one we did meters, and we learned that Mason ran 620 meters to Lacey's 930 meters. These are all equivalent ratios because they have the same tape diagrams. So this next one I'd like for you to work independently, and we will go over this in class to check your work. It has a few parts, so take your time, go through them, and we will make sure that we Sorry, that was weird. We will make sure that you understand all of this and have got it under control when we go over it in class. So here's our lesson summary. 2 ratios, A to B and C to D, are equivalent ratios when that number C, which normally stands for constant, you multiply by the first number, first ratio, to get the second ratio. And they are equivalent if there's that number C. So that's what it's about. We're going to practice it and talk more about it next time.